In the stepping motor, there is no carrying of winding on the rotor side. The stator flux causes the rotor movement through a single step, so that reluctance seen by the stator field is minimum and the stator flux linkages are maximum for the given stator current. That we'll see through the diagram. When the diagram comes, you will clearly understand. When the stator as well as rotor directions are aligned, so the flux linkages will be maximum, thereby reluctance will be minimum at that particular path. So the flux linkages will be maximum. What they will try to do is reluctance will be minimum at the direction such a way that the flux linkages will be maximum. What the reluctance try to do is reluctance will be minimum at the direction such a way that for your the flux linkages will be maximum. So if you see reluctance will be minimum at the direction. Suppose if you take one the flux linkages will be maximum. So variable reluctance will be minimum at the direction. Suppose if you take one the theta is having 6/2 theta is maximum. So variable reluctance will be number of polyhedral. Suppose if you take one the theta is having 6/2 theta is maximum. So variable reluctance will be number of polyhedral. Suppose if you take one the theta is having 6/2 theta is maximum. So this is either connected in series combination or parallel combination, such that this stator has effectively three windings, either connected in series combination. Okay, so as we know that such that this stator has stepping machine effectively three windings, either connected in series combination. Okay, so as we know that such that this stator has stator effectively three windings, either connected in series combination. Okay, so as we know that such that this stator has stator effectively three windings, either connected in series combination. Okay, so as we know that such that this stator has stator effectively three windings, either connected in series combination. Okay, so as I know that this stator has stator effectively in other words 0 degree. So when AA dash is energized, so the angle assumption difference is how much? For the stator and rotor field, 0. There is no angle difference. But when BB dash in this direction, excitation is given and this AA dash is de-energized. Okay? The angle now will become from here to here, theta will become basically the 60 degree, because totally how many we are having? 6 parts. So 6 parts. Total 360 degree. Here to here how many degrees? 60 degrees. So one part means the rotor is getting rotated with a step of 60 degrees. So the rotor now it will rotate here as BB dash is get energized. Similarly, BB dash when it get de-energized and CC dash energized, then your rotor will turn into here. So every time the rotor is going to have a shift of 60 degree. So it will rotate in the clockwise direction. Here the direction is given as clockwise direction because we are de-energizing AA dash and energizing BB dash. Okay, for that reason we can have this kind of rotation. So in 6 steps the machine will going to complete a one single rotation. In other words, 360 electrical degrees. So the step angle, how we can measure the step angle, is given as 360 degree divided by MP. Okay, na? So that only I have written here. In this manner, the rotor complete evolution. So 6 steps, because we are having there 6/2 stepping machine, where you can see that 6 number of stator salient poles and 2 number of rotor poles. So that will be represented by like this 360 by M into P, where M is number of phase windings in the stator, 3 phase winding, P number of phases per winding, 3, and P number of rotor poles on teeth. M is the number of phase windings on the rotor, that is three, and P is how many poles which are there on the rotor, two only. So this becomes six number. MP is becoming now six. So 36 will be equals to okay. Na? So this is what your variable reluctance stepping motor. Coming to variable reluctance motor. So this is same kind of more or less same machine only, but with some differences. See how this particular variable reluctance motor, that is VRM, so will be different from the just now we have discussed about variable reluctance stepping machine. This is basically it is also termed as the switch reluctance motor. Just a second, please wait for 1 minute. So another type of machine that is see that variable reluctance motor. So it is also termed as a switch reluctance motor. So the this is to indicate that switching inverter is required to drive the variable reluctance motor. The name so variable reluctance motor. It is also called as switch reluctance motor. So why it is called as switch reluctance motor means that requires actually some kind of inverter, switching inverter to drive this particular machine. So principle of operation basically same as variable reluctance stepping motor, whatever we saw just now. So when the supply is given through one phase, so in that phase, the rotor is going to get aligned with another pair of poles of the stator if they are energized and previously got de-energized. So in this direction, it is going to align. So likewise, it will complete its rotation. Okay. Na? So see that some even though it is having some similarities between variable reluctance stepping motor, it is differentiate from other machines in some other way. So in other words, VRM, that is variable reluctance motor, that requires a rotor position sensor. Requires a rotor position sensor, whereas in the variable reluctance stepping motor, it is not required. So variable reluctance motors, that is VRMs, those are designed for continuous rotation, whereas variable reluctance stepping machine or motor, whatever we saw just now, that is designed for the rotation of the steps. So there exists some kind of the difference between this variable reluctance machine as well as synchronous machine is that synchronous machine has got cylindrical starter structure with the distributed windings and solient pole rotors with a concentrated field windings. Whereas the VRMs will be having concentrated windings on the stator pole and it does not have any kind of winding on the rotor part. Okay? So you see that synchronous motor can be run as brilliant pole synchronous motor with field winding energized and as a synchronous reluctance motor. With field winding, de-energized means if the field winding is not considered, it is not de-energized. So synchronous motor is expected to consider as variable reluctance motor. This reference we go to next. So this VRM got main advantages and the speeds can be easily adjustable due to its some kind of the features like they are very simple in construction as they are not having any winding on rotor. So thereby costs for this particular machine also will be going to reduce. As it is not having any kind of winding on the rotor, it is expected to rotate with huge amount of speeds. Say it is about it can rotate about 2 into 10 power 6 RPM, which is very speed considerations. So the cooling of this particular stator winding can be easily done. So due to that effective cooling of the particular stator decreases for the given machine rating because in the rotor part we don't have any kind of the windings. So with that size is already reduced and another part is that effective cooling can be done. So with the effective cooling the machine can be made further compact for the given same size. So the particular variable reluctance machines are functional drive circuits. So hence the cost of that micro as well as all electronic circuits is going to be get reduced. So as we discussed earlier, the stator winding can be cooled easily and efficiently. The variable reluctance machines can operate successfully though at reduced outputs, even if one or more phases are out of circuit due to some fault. Means in the when the particular VRM variable reluctance motor is operating, even though if it is fault in the other phases, if it is three-phase machine, even though if it is faults, it is having faults in the other phases, so remaining phases will continue to give supply. Means it can have the effective operation. You know, so these are the main advantages of the variable reluctance machines, and they can be used highly with the uh, P drives due to the following advantages. So see that the coming to this constructional features, the VRMs variable reluctance machines can be either singly salient construction or doubly salient construction. You can see that. So let's see all of you. This is what your so this is what singly salient structure. This is what your doubly salient structure. Doubly salient structure. You'll see that. You'll see what are the differences, key differences between these two structures. So see that the singly salient variable reluctance machine consisting of non-salient stator. This is a stator which is having non-salient stator, not projected out. So this is what your non-saliented which is having a non-salient stator and two-pole salient rotor. Rotor has no winding, but cylindrical starter has two-phase winding as shown. So the winding, that's why you see that A dash phase, B dash phase. So whatever the winding, whether it is singly salient construction or doubly salient construction, so they will be basically limited to two-phase system. So that's why we have written rotor has no winding, but cylindrical starter has two-phase winding as shown. The inductance of each stator phase winding varies with the rotor position. So it will be maximum when the axis of stator phase winding coincide with the rotor axis. So inductance. So inductance will be maximum. So in this position, when the stator as well as rotor axis are the coinciding. So in this way you see that. So in this way, the rotor axis and stator axis are going to be coincide. In this way, as the flux linkage is maximum, hence the inductance will become maximum. So for that reason, we have written that the uh, maximum inductance can be observed when axis of stator winding coincide with the rotor axis. So like this. So we will see in the short while. So this is what your uh, two structures of singly salient construction and doubly salient construction of the VRM, variable reluctance machines. So now coming to doubly
మన డేటా
salient
అయిపోయిందా?
VRM. This consisting of four salient poles which are shown in the figure. On the stator winding and rotor has two salient poles with no winding. Anyhow, in the stepping mechanism, motor or salient reluctance motor, we don't have any kind of windings. Okay, now so see that as I just told you, so both VRMs, either it is singly salient VRM or doubly salient VRM, they have two phase stator windings and a two pole salient rotor. So whatever the number of this stator poles are there, so we will come back or take back to that into two by means of some construction to the winding. Then now coming to the principle of operation of this VRM, variable reluctance machine. This is same as that of variable stepping motor. Number of this stator, whatever the poles are there. Principle of action is there. Take back to that the reluctance mechanism by means of rotor is going to get rotated. So in that same principle only it will follow. VRM principle of operation of this VRM, variable reluctance. So in this you see that this is same as that of VRM, variable stepping motor. Number of variable reluctance machine. Stator whatever having poles are there. 6 number of stator poles. 1, 2, 3, 4, 5 and 6. And 4 number of the rotor teeth or rotor poles are there. Okay. Suppose say if phase winding A is excited, this winding is excited, and the rotor, suppose say it is achieved here in this path, it is there. Rotor, because the field flux will be get generated. So now what is the direction of rotation of this particular rotor? It is rotor will try to catch the low reluctance flux will be low reluctance path means rotor does not move in this direction because get generated here to here. So now what is the direction gap is the air gap is there means reluctance is rotor will try here this catch the low reluctance path will be what is the air gap that you can see low reluctance path means the rotor does not move in this direction. This rotor is because get generated here towards B. So now what is the direction gap is the air gap is there. The rotor will try